Lesson 11 is called the most important property of logarithms. So we're going to explore another property to add on to the one we talked about in lesson 10. And so it says, use the logarithm table below to calculate the specified logarithms. So they start us off with log 80. And so what they want us to do is they don't want us to go into the calculator and type in log 80. They want us to try to use this table in a way that makes sense by applying the properties. And so since this is an opening exercise, we assume we're going to use the property from lesson 10, such that if I have 80, this would end up saying log of 10 to the first power and then times 8. That's an equivalent way to write 80. And so with that being the case, we can now say that this is going to be 1 plus log 8. And so now if we looked up log 8 in the table, it tells us that log 8 is 0.9301. So this ends up being equal to 1 plus 0.9031. So we find out that our answer is 1.9031. So we did the same thing with 7,000, right? This is 1,000. So this would be essentially saying like log of 10 to the third power, and we're going to multiply that by 7. So that means we're going to end up doing 3 plus the log of 7. So we look it up, right? We use our table. 3 plus the log of 7 is 0.8451. So we find out our result is 3.8451. Now again, we look at this one and it's going to be, we need to move our decimal place. So 1, 2, 3, 4, 5 places. So this is the log of 10 to the negative 5th times 6. So we'll end up doing negative 5 plus log 6. So we look it up. Negative 5 log 6 is 0.7782. So we add those together. And you might want to grab a calculator if you're not certain on this, because this is a negative 5. And so you're going to get negative 4.2218. Letter D is already set up per se. So we can rewrite this as 10. Well, it's already 10 to the 27th times 3, but if we just want to rewrite the order, it would be 10 to the 27th and then times 3. So that means we're going to do 27 plus log 3. So that would be 27 plus log 3 is 0.4771. We add those together and we're going to get 27.4771. And so if we did it with letter E, it says if we rewrote this as log 10 to the k power times 9, that means that would be equal to k plus the log of 9, which means this would be equal to k plus 0.9542. So that is our opening exercise to review what we just did. They have in exercise number 1, they ask you to use your calculator to complete the following table. Round the logarithms to 4 decimal places. And so they already did the one on the left. This is our basic log table. It was also in our opening exercise. So if we did log 10, we would get 1.0000. And then if we did log 12, we would get 1.0792. Remember, it said to use your calculator. And then log 16 would be 1.2041. Log 18 will be 1.2553. And then we have 1.3010, 1.3979, 1.4771, 1.5563, and then we would have 2.0000. So we're going to use these tables to help us do some logarithms on the next page, because we're going to discover another property. So it says in number 2, calculate the following values. Do they appear anywhere else in the table? So we'll start by looking at this. They say log 2 plus log 4. So we're going to look it up. Log 2 says 0.3010. We're going to add that to log 4, which is 0.6021. So when we do that, we end up adding those two together. And when we do that, we get 0.9031. And it turns out that if we were to scan our table, 0.9031 is right there. So that's approximately the same thing as log 8. So again, remember, the goal of this is to discover a property. So I won't say anything, except for you might want to think about that 8 and its relationship to a 2 and a 4. So now if I did the next one, right, log 2, we already know is 0.3010. We're going to add that to log 6. We looked that up. That says 0.7782. And so when we add those together, we get 1.0792. So we look, 1.0792 is 12. So that is approximately the same thing as log 12. If we looked at this one here, log 3 is 0.4771. We're going to add that to log 4, which is 0.6021. We add those together. That gives us approximately 1.0792. Well, we just got that answer. And so we know that's approximately log 12. If we did log 6 plus log 6, so that's like adding up 0.7782 plus 0.7782. So when we do that, we get 1.5663, and we find out that is approximately the same thing as log 36. If we did letter E, log 2 is 0.3010, and then log 18 is 1.2553. So if we add those up, we're going to get 1.5663, which is again approximately the log of 36. I bet you might see a pattern happening, but let's do one more just to make sure. And so if we did log 3, log 3 is 0.4771. We're going to add that to log 12, which is 1.0792. So we add those together. That gives us approximately 1.5664, which is again log 36 based on the table. So by now they're asking you to say, well, something interesting must be going on. What patterns can you see in exercise 2 from the table? And from exercise 1, write a logarithmic notation that describes that. Well, what we discovered is it turns out that if I have log x and I add that to log y, that is equivalent to the product of log x times y with a single log. What pattern would I expect to find with a log x squared? Make a conjecture. And so we see a log x squared, right? So a log x squared is the same thing as saying log x plus log x. And since I have two logs like this is equivalent to 2 times log x. Number 5, make a conjecture for the logarithm of log x times log y times log z, where they are all real positive integers. So that means if we see a log with an x times a y times a z, that would be equivalent if I did log x plus log y plus log z. So what we're going to do in example number 1 is we're going to test some of these ideas. And so if we see log 14, I can replace that with log 2 times 7. And so since now I know the relationships that are going on, I can rewrite this as log 2 plus log 7. And so we can use our log tables from the previous pages, and we can recall that log of 2 is 0.3010, and log 7 is 0.8451. So we can add those together and find out that log 14 is 1.1461, rounded to 4 places behind the decimal. So we do that with log 35, right? We could say that this would be log with a 5 times a 7. So we could rewrite this as log 5 plus log 7. And so log 5 is the same thing as 0.6990. And this one is 0.8451. We learned that from right here again. And if we add those together, we get approximately 1.5441. If we did log 72, that would be like saying the log of 8 times 9. So then I can rewrite this as log 8 plus log 9. So log 8 is the same thing as 0.9031. Log 9 is 0.9542. If we add those together, we find out the log of 72 is 1.8573. And then we can wrap up this example by doing 121. And we could say log of 121 is the same thing as saying log of 11 times 11. Since we don't have a value of 11 in the table, in terms of our perspectives, we cannot evaluate at this time. Now, that doesn't mean that you can't evaluate, okay? You could type in your calculator, and you could type in log 121, and you could press enter, and we do find out that log 121 is approximately equal to 2.0828. But understand, they want us to use the log tables from exercise 1. And so when I say you can't evaluate, it's because we were not able to create, develop, or alter our numbers in such a way to create the 11 in that log table. So that's why the result was cannot evaluate. If we look at number 6, it gives the same idea. They give us these log values here. And so if we did log 2, right, this would be 0.3010. Log 4 would be 0.6021. If we did log 5, that would be 0.6990. Then we would have 0.9031. This will be 1.0000, 1.2041, 1.3010. This would be 1.6990, and this would be 2.0000. Here's what they want you to note is, what if I had 1/2, 1/4, 1/5, 1/8, right? These would be like the inverses of each of these. And so we took the reciprocal of the fraction, made 1/2. And so that would just give us negative 0.3010 or negative 0.6021. We're not going to fill them all out because you get the idea. Negative 0.6990. I'll do another one. Negative 0.9031. And this would be -1. And it would continue in the exact same pattern in that perspective. So they asked in 7 is, what patterns can you see from exercise 6? Write a conjecture for this idea. And so what we find out is, if we take a log of some 1 over x, we find out that's exactly the same thing as saying -1 times the log of x. So this will be another property that we will take advantage of in that perspective. So we're going to skip number 8, and we're going to look at some examples that model this concept. So they say, what if we have the log of 2,100? Okay, so they want us to use our log tables and log rules that we discovered. So we're not going to type in log 2,100 in our calculator. We're going to apply our rules. So if we look at this, we say, oh, well, okay, I could take this and I can rewrite this as the log of 10 squared times 21. So if I do that, what I'm going to do is I'm going to make some more room real quick before we talk about that. So there we go. That gives us room to write. So now if we pick up where we left off at, we now can rewrite this as 2 plus the log of 21. Now, log 21 is not in my table, so I can rewrite this as 2 plus log 3 plus log 7. So when I do that now, I've got 2 plus log 3 is 0.4771, and log 7 is 0.8451. So I find out the final answer is 3.3222. So again, remember, our goal is to reference everything back to our basic log table that we used at the beginning of the lesson. So if I did the next one, this would be 1, 2, 3, 4, 5 spaces to get all the way to the end. So I would have log of 10 to the -5 times 49. So that means I can rewrite this as -5 plus the log of 49, and then I can simplify by saying this is going to be log 7 plus log 7. So I get -5 plus 0.8451 plus another 0.8451, and I find out that my result is going to be -3.309 and then 8. Continue what we're learning, right? This is 1, 2, 3, 4, 5, 6 zeros. So I can rewrite this one as log of 10 to the 6 and then times 42. So that's going to give me 6 plus log 42. So that is 6 plus log 6 plus log 7. So I get 6 plus 0.77 0.82 and then plus 0.8451, and that gives me 7.6233. And then if we looked at the last one, right, I'm going to actually give us more room, so I'm going to copy this one. We're going to edit, we're going to paste it, and we're going to put D right here. That way we have room to actually solve D. And so if we were to write this, remember this is written as a fraction. So it says, if I write it completely as a fraction, it would look 1 over 640. That's just for visuals. And so if we have that, we learn in our rule that we could write this as the negative log of 640. So now we have our negative on the outside. And so now we could do negative, and I'm going to put these in parentheses because everything we'll be doing is that negative applies to everything I'm going to do. That'll be 10 times 64. And so now I can rewrite this as 1 plus the log of 64. And then I can rewrite this as negative 1 plus log 8 plus log 8. So that's 1 plus, and that is 0.9031 plus another 0.9031. And so our final answer ends up being negative 2.8062. All right, so that is our the end of this particular lesson. Just to remind you, in all of this, there was 2 properties that we pulled out. One is that if we have log x plus log y, that is equivalent to log x times y. And if we have a log of a 1 over x, that is equivalent to negative log x. So those are the 2 properties that we want to apply and make use of.